This algorithm is on solving linear congruency using the Chinese remainder theorem. So let me go through a scenario. You have a bag of golf balls. How many bags of golf balls? We're not sure. We don't know how many got. But if we take 3 balls at a time, we have 2 left. The other scenario is that if we take 4 balls at a time, we have 1 ball left in the bag. So you see of all these balls in the bag, when we take 5 balls at a time, we have 3 balls left. So the question is, what is the minimum number of balls in the bag? So how many balls are in the bag? So how do we figure this out? How many golf balls are in the bag? So my goal is that to solve this problem, using the Chinese remainder theorem. So what I'm going to have to do from the first scenario here, I can draw this. So you see x is congruent to 2 mod 3, because when we took 3 balls at a time, we have 2. Second one, when we took 4 balls out, we have 1, and so x congruent 1 mod 4. And then the third scenario, when we took 5 balls out at a time, we have 3 left, so 5 out of 3. So these are my x's. So now my goal is to figure out what is the minimum number of balls, how many balls were there. So if I go through this scenario, I'm going to go A1, M1, Y1. Okay, so we'll figure out A1 and M1. I need to get a value for Y1. A2, M2, Y2. A3, M3, Y3. A4, M4. And then I'm going to mod it by M. And M is 3, 4, and 5. Now, 3, 4, and 5, these are co-primes. They are co-prime. What is a co-prime? Co-prime means that if you take the GCD of any of these two numbers, it's 1. So let's continue with this problem and see how we're going to solve this. So how we're going to figure out what x is. Now, as I mentioned, x 4 and 5, 3, 4, and 5 are co-prime. That's very important. Okay, so I'm going to write this out. So in this case, I have this scenario here where I have A1, M1, Y1, A2, M2, Y2, A3, M3, Y3. So that goes on, and like I said, so if I look at A1, so in this case, this is 2, because I'm looking at this one. And now, what is M? M is actually 4 times 5. See, I have to take, and this is Y1 plus A2. And A2 is actually 1 times, and this would be 3 times 5. And that's Y2. Now, A3 is 3 there. So A3 is actually 3. So that would be 3 times, and in this case it's 3.3 times 4. And this is Y3. So you see, I use 4, 5, leave out the 3, 3, 5, leave out the 4, 3, 4, leave out the 5. So if I solve this one out, so this is going to be 20 Y1 plus 15 Y2 plus 12 Y3. So how do we solve for XY, for Y1, Y2, and Y3? So I'm going to go into put this congruency here. So that's going to be 20 Y1 congruent to 2, okay, mod 3. Okay, so 3 mod 2. Now, to solve for Y1, I need a number. So if I take 20 mod 3, 20 mod 3, so that's 6, that's 18, so 2. So I have 2 Y1, okay, and this is mod 3. Now in this case, I need a number. I need a factor. When I multiply it by 2, mod it by 3, I should have a 1. So what would happen? The best way to do, multiply this by 2, so that would be 4. 4 mod 4 mod 3 would be 1. So 4, 1, so this would be 4, okay, and this would be mod 3 actually. That's it 2. Alright, so that's it 2. So therefore, 4 mod 3 is actually 1. So this is y1, 2 mod 3. So in this case, y1 is 3. y1 is actually 2, sorry. y1 is 2. So now I got y1. Now I'm trying to solve for the next value. So here, let me write these out here. So y1 is actually 2. I'm going to save this. Now I'm going to continue with the next value. So my next, okay, let's do my next equation here. So that would be 15, let's see this one, y2, congruent to 1 mod 4. Congruent to 1 mod 4. See that? That's my 1 there. So now, in this case, well, 15 mod 4, the answer, so that would be 3 for them. So this would be 1 mod 4. Now I need a factor. When I multiply it by 2, by 3, I should have a remainder of 4. How about 3? 3 times 3 is 9. 9 mod 4. So that would be a 1. So that's perfect. So if I multiply this by 3, so I get y2. So that's a 3, and this is mod 4. Now 9 mod 4 is 1, so this is y2, which is 3 mod 4. So therefore y2 is actually 3. So I solve for y2, which is 3. So I'm going to write that here. So y2 is now 3. Okay, so let's continue with the third one. Now the third expression is going to be 3. Okay, so that's a 12. So it's actually 12 y3, and what is that? It's 1 mod 5. 1 mod 5. Now in this case, it's 5 by 12 mod 5. That gives me 2. So 2. So what does that mean? So I have, if I take 12 and then mod it by 5, 10. So remainder 2. So now here, I need a term, a factor. When I multiply it by this coefficient, this number here, 2, modded by 5, I should get a 1. So the best way is to multiply this by 3. So if I multiply this by 3, that's going to be 6y3, and that's going to be 3. Remember, I multiply this by 3, mod 5. If this is the case, so 6 mod 5 is 1. So this is y3, 3 mod 5. Now, in this case, y3 is now 3. See, so now I got the value for y3, which is 3. So all I have to do now is actually plug it in. So I'm going to have to go into this equation. So that's 2, that is 4 times 5, that's a 20, y1, that's a 2, plus 1, this is 15, y2 is actually 3, this would be 3 times 12 and times 3. So in this first value, so this becomes 80, and this is 45, and this is 108. So when I add these up, if I add all these up, I end up with 233. So now this is x. So now, well, what's the minimum value of that? So I'm going to take this number, which is 233, I'm going to mod it with m. And remember, m is 4 times 5. times 3 times 4 times 5, and that is 60. So 60, so 233 mod 60 gives me an answer of 53. So this is the minimum number of golf balls in the bag, and this is how we solve this linear congruency using the Chinese remainder theorem. Thank you.